Morning, sir. My name is Lakshman of Electrical and Electronics Branch. My roll number is 2095580 Today, my topic is about a converter based starting methods and a speed control of double fed induction machine with centrifugal loads. And the adjustment speed drive is attractive for pump and compressor and other centrifugal loads applications due to its flexibility and high operating efficiency compared with the conventional constant speed drive system. Converter based starting method for a double fed induction machine with centrifugal loads by constant voltage per head control, and instead of using the additional starting resistor or auto transformer. The grid synchronization scheme is the developed to complete the transition of transition from motor starting to vector control speed regulation in the high speed region, and therefore the machine can successfully operate in the full speed range by combining constant voltage per head control and the vector control. Since the centrifugal loads torque reduce the quickly with speed square and the partially rated converter may be provide enough torque at low speeds. Two starting alternatives can be used according to different turns and between the machine stator and rotor winding. The proposed control scheme can be simple implemented with one quadrant partially rated power converter, and the voltage and current rating of the converter are carefully designed considering the centrifugal loads characteristics and the operating speed range. Some important applications issues such as a soft grid connection and the rotor position estimation are also discussed. The proposed control schemes are can be has been validated by the simulation and experimentally verified through the DSP controlled 30 kilowatt double fed induction machine system by starting from the rotor side. The drive system can be successfully run in the full speed range with the proposed control method and the control sequence. And the double fed induction machine with vector control is very attractive uh, to high performance variable speed drive applications. So that's so called slip power recovery scheme is a common practice where the power due to the rotor slip below or above the synchronous speed is recovered to or supplied from the power source and resulting in the high efficiency variable speed system. The fundamental feature of the double fed induction machine system is that the power processed by the power converter in a only slip power, which is a fraction of total system power. And the case of centrifugal loads such as the pumps, compressors, or fans, the control of various slip power recovery circuit topologies such as their static Cormacher if the machine is operated within the limited speed range around the synchronous speed, which means small slip, then the power converter rating can be reduced significantly, which suits the circuit and the static scrubber circuit, and mm, most of which employ either a current field natural commutator DC link converter or a cycloconverter in the rotor circuit. And two topologies such as a poor power factor and harmonic distortion and extra force commutation at signal speed and can over by the using the voltage source and pulse width modulation PWM converters. It includes the sensorless drive and the brushless double fed induction machine design and the use of double fed induction generators for the wind power applications. One issue of the slip power recovery circuit is that the power converter rating is only scaled and designed to handle the slip power within the small setting speed around the synchronous speed, and for the speed outside the preset speed range, and the converter loses its control capability. Therefore, the machine is started by using either additional setting resistor or auto transformer to accelerate the setting the speed range. Then the power converter takes over the speed control of the machine. Obviously, the use of starting resistor and the auto transformer increase the system size and the cost. And the purpose to use the power converter to start the machine with the help of starting resistor and the auto transformer by constant voltage and frequency control. And since the power converter is usually partially rated to handle the machine slip power, the starting method with constant voltage and frequency control can be provide the limited torque at the low speed range, which suits the centrifugal load's characteristics, and the load reduces the quickly with the speed squared. And the speed range is divided into two parts by the synchronous speed, which the different control strategies and the constant voltage and frequency control and the vector control are applied respectively. And the motor can be successfully started by the power converter. The setting speed range can be chosen about the machine synchronous speed. Therefore, the control schema can be simple implemented with the standard one quadrant motor drive converter, and which is the double fed induction configuration, and which is given to the load. First of all, we are generating the power, and it is given to the rotor side converter and the grid side converter, and in between we have the capacitor which is the ripples, and it is given to the grid. And it will have the machine 1 and machine 2, and the load is DC generator for the load purpose. And that is the typical power speed curve for the centrifugal loads, which have the x-axis is speed and y-axis is power per unit power, and the load power and converter power. It is the low speed range and the constant volt by frequency, and the right side is the setting speed region and vector control, that is the constant voltage by frequency control and vector speed control. We have the speed omega 1 and omega 2, and the omega 3 is the peak value, and the line which is starts from the 0, and which is speed is in between that. And the control strategy design, the system layout and control sequences. The based system configuration of the double fed induction machine rotor winding is connected to the grid through a switch KM1, and while the rotor's winding is connected to the via grid via 2 3 phases voltage fed converter. In order to adapt the standard one quadrant motor drive converter topology and reduce the system cost and the control complexity, and a rotor side PNW converter as a grid side diode bridge converter is used. And therefore the double fed induction machine setting speed range is designed about the machine signal speed, and therefore the double fed induction machine setting speed range is designed about the machine signal speed, and the slip power only flow from the rotor to the grid. The converter also be to fully converter 3-phase PWM converters to be obtained subsynchronous and the super synchronous setting speed range and operating, and the control schema for the grid side converter can be found. A DC generator with a resistive load is used for illuminate emulate the centrifugal load with the shaft connection to the double fed induction machine. The grid side diode bridge converter may be reduced the system power factor, and although converter will be used. Meanwhile, the rotor side power electronic converter can introduced with switching harmonics to be double fed induction machine and the grid. The certain filtered inductance may be added at the double fed induction machine rotor side to meet the harmonic requirement for the double fed induction machine and the grid. And it is the flow diagram of induction machine, which is the first one is the start and the system analyzing and the km1 and the closed and km1 is open, and the start the and the accelerator the motor by the constant voltage by frequency control. The motor speed control and reaches the speed, and the desirable rotor side converter PNW signals at the wait for the stator current, which is given to the KM1 open and the K2 is also open. Re-enable the rotor side and the PNW grid synchronize the starts. The voltage, amplitude and the angle and frequency adjusted. Next one, the voltage, amplitude and the angle errors enter to the setting tolerance, and the KM1 is closed and connected to the machine rotor side to a grid and vector control for the double fed induction machine. The speed is reference and this compares to the different speed and the normal rated speed. KM2 closes and KM1 is open. Constant voltage and frequency is controlled, and this is the required converter voltage and current from different speeds. The x-axis is speed and y-axis voltage and current per unit values, which is given to the dotted lines are required. It represents the required converter current, and the which is does not have dotted lines, straight line, which is depend the required converter voltage. We have the low speed region and the setting speed ranges up to 0 to 0.65. it is increased and it is decreased, and once again it is given to the linear motion. And this is the vector control diagram for the double fed induction machine, which have the converters and DC link and rotor side converters and the decoupled errors and the P1 and P2. All these are converters which is used in this system. And there is the grid synchronized control diagram for the rotor side converter. We have the power supply, and it is a closed loop function which controls the speed and starting methods of the system. Thank you, sir.